Okay, let us discuss the problem 1.68. So we are going to discuss problem number 1.68. So what this problem says, so let me read. So let me first draw the diagram. So we have a 1.14. So diagram is something like this. This has a mass m and there is a force that is acting in this direction F, and this makes an angle with the horizontal. So this angle is alpha. Now at a moment t equals to 0, a force F is equals to at is applied to a small body of mass m. So this force is basically a into t, and this force starts at t equals to 0. So at t equals to 0 there is no force, you can see here, and a smooth horizontal plane. So this plane is smooth, so mu is equals to 0, you can see. So this plane is a smooth. Now the question says the permanent direction of this force forms angle alpha with the horizontal, that is the angle alpha. So this forms angle alpha with the horizontal. The velocity of the object or body at the point when this leaves the plane breaking off. So we have to find what is the velocity of this mass m when this leaves the plane. So when the leaves this plane, so this means breaking off. So when this object break off, what is the velocity? We have to find out. Next part, what is the distance traveled by the up to this moment? So what is the distance traveled up to this point when the breaking off happens? So when the breaking off happens, what is the total distance covered up to this point of time? So we have two parts. Now I will give you a hint and then you can do this problem. So this force, you can take component of this force in horizontal and vertical direction, and then let me do some more work so that you can have good idea. So let me break here itself, so you will have, so or I can do it here. So this force is acting in this direction. This force will have a component in this direction. So this angle is alpha, so this will be F cos alpha. Now this angle is, now in this direction you can say F sin alpha. Everybody agree, I think. Now there is a force that is acting downside, that is mg. On this object there is one more force that is acting in the vertical direction, there is a normal reaction. So you see in the vertical direction two forces. Now you write down the two equations and find out a time when normal reaction becomes 0. And then you also find out the acceleration, and then you do some integration work, you find out the velocity. And once you find out the expression in terms of velocity and time, you again convert this expression into time and displacement, and then you again integrate, you will get the answer. Are you getting or not getting? Okay, once again let me explain. You have direction in x, what is the force in the x direction, so you can find acceleration in the x direction. You can also find velocity in the acceleration x direction, because if you know the acceleration you can integrate, you can find velocity. You find the time when the normal reaction becomes 0, because force is a function of a into t, so you can find a time when the normal reaction becomes 0. Let me do this one. So if you see in the horizontal direction, what are the forces acting? F cos alpha, there is no friction, so F cos alpha is equals to mass into acceleration. So let us call this is a acceleration, let us call A1. Are you getting also? We are calling A1 as acceleration. Why this is so, you will understand, because there is a already. So or you can change this A as a alpha, that is another issue. So let us say F cos alpha. So now I have acceleration is nothing but F cos alpha by mass m. But what is F? F is nothing but A into t, so I can also write at cos alpha by m. So this is my acceleration. Are you getting? Now let me find in vertical direction the total force is, let us click downward as positive, mg minus epsilon alpha minus n. This is the vertical direction force, so force in the y direction. Are you getting or not? There is no motion in the y direction, so total force has to be 0 because this is not lifting up in the y direction. So this is Fy, so Fy has to be 0. Now there is a point when this just breaks off, so at the point of breaking off, normal reaction will be 0. Are you getting or not? So this will be 0 at the time breaking off happens. At the time of breaking off, let us say this time is t naught. Are you getting? So when the breaking off happens, time will be t naught. So now I can write mg minus, now force is what? Force is a into t, you see here. So this force is a into t and time is t naught, so I can write a into t naught. So from here I can find t naught. So what is the t naught? T naught is mg divided by a sin alpha. So simple. Are you getting or not? So this is my time. Up to this time, now I have acceleration. So acceleration is nothing but a1 is at cos alpha by m. So acceleration can also be written as dv by dt. So dv by dt is at cos alpha by m. Are you getting? So this is the velocity now I can find. So we have to find, let us do the first part. What is the velocity at the time of breaking off? So now if I integrate this one, so this is dv is equals to a cos alpha by m, because cos alpha is constant, t dt. I have to integrate, and this t goes from 0 to t naught, and t naught, you know what is this value of t naught here, mg by a sin alpha, and velocity, initial velocity is 0, and let us say that at this time velocity is v naught, and what is the value of t naught, that is mg by a sin alpha. So this becomes a cos alpha by m, and integration of t is 2t square, so t square by 2, so 2 let us put it here. So this is the, now if here you will have v naught, dv integration v naught is equals to a cos alpha by 2m, and t is what? T square is m square g square by a square sin square alpha. Are you getting? Now so finally if you do some more calculation, if you do some massaging of equation, you will find, so this m cancels out, so we will have mg square on the top, 1m cancels out, you will have 1m and g square cos alpha y sin alpha cot alpha, and again 1 sin alpha will remain in the bottom, so let us put 1 sin alpha, and 2 is there. We have written everything, a square, so there will be a also in the denominator. Are you getting? So this is the final expression, mg square cot alpha 2a sin alpha. So let me check this answer whether they are giving the same answer or not. So this is the problem number 1.68. So they are giving a t naught square cos alpha divided by 2m. Where is the mistake? So we have some mistake. So let us check. So t naught, so what is the t naught? T naught is mg by a sin alpha, and omega is this cos alpha. So t square by 2. So everything is right, I think. So v naught should be mg square cos, oh it's right, they are also giving the same answer, mg square cos alpha divided by 2a sin square alpha, mg square cos alpha, that is here, mg square cos alpha a. So we are getting the same answer. Are you getting or not? So let us copy and then we'll go for the next part. Okay, if you have copied, then I can go for the next part. Next part is easy. So what I have to find is, you have to find what is the distance traveled. So you see, I can go from here up to this time, what is the distance traveled. I can manipulate this equation again, and then I can write. So what can I do? Can anybody help me? Any idea? No idea. So what can you do? How do you change this equation to find out the distance? So I can write this equation as, so I can write dB by dx and dx by dt. Are you getting? This is equals to at cos alpha by m. So let us write a cos alpha by m into t. Are you getting? Now dx by dt is what? V. So you will have v dv. Let us take, so this is v, so this is v dv. Are you getting? Now if I take this is dx by dt is v, so I have to eliminate t. Are you getting? So that I can, so basically I want to find displacement distance, so I have to eliminate v. So how can I do that? Yeah, I can do. So what is this? So dv, this is v. Okay, let us write here because we don't have so much space. So this is v dv by dx is equals to a cos alpha by m into t. I have to eliminate t and then I can integrate. So how can I eliminate t? Any idea? Can I integrate now? We cannot integrate because we have dv dt. So I have to eliminate t. How can I do that? Any idea? So what we have done perhaps might be, so from here I think, so if you see this equation dv by dt, from here I can find v and then I can use dv by dt. So let us cancel this one. I cannot do because I am getting something time here, so I cannot integrate. So what can I do is, so let us do something different. So here you have, so let us again copy this one, dv by dt. Here up to right we have dv by dt is equals to a cos alpha. Are you getting or not? So this is a cos alpha by m into t. So this is dv by dt. Now if I integrate this dv by dt, and let us take dt that side, so a cos alpha by m into t. If I take this dt that side, so this becomes dv is equals to a cos alpha by m into dt into t. Are you getting? So this is t dt. So now I can integrate. So dv is equals to a cos alpha by m t dt. Now let us integrate. At t is equals to 0, velocity is 0. Let us say t is equals to t, velocity is v. So I have v is equals to a cos alpha by m and t square by 2. So this is simply t square by 2. Now again I can write v is dx by dt. So I have to integrate 2 times a cos alpha by 2m into t square. If I can do once again integration, dx is equals to a cos alpha by 2m t square dt. So at x equals t equals to 0, x is equals to 0, and t equals to t, x equals to x, that is we have to find. So the x equals to t is equals to t naught. What is the distance traveled? So this becomes x is equals to, so tq by 3. So this is simply 6. So tq a cos alpha, so a cos alpha by 3 into 2, 6m. Are you getting? And this is t naught. What is the value of t naught? If you see in the first part of the problem, we have said what is the value of t naught here. So you see, so t naught is mg by a sin alpha. So you see here, so t naught is nothing but mg by a sin alpha. So if I plug the value, t is equals to mg by a sin alpha, t naught is equals to, so I will get mg by a sin alpha whole cube a cos alpha by 6m. So this is mqzq, and here you have aq, that is 1 aq, and so this is a square. Cos alpha on the top you will have, on the bottom you will have sin q alpha, and 1m also cancels out, so you will have m square and then 6. So you will have m square zq cos alpha by 6 squared sin q alpha. Are you getting? So what we have done, we have integrated 2 times. So let us write and then we will go for the top so that you can also write that one. This problem becomes slightly bigger one, but the concept is okay. There is no concept in this problem, but complex concepts is not involved. So you see what we have done. We have found velocity as a function of time. So velocity as a function of time comes out to be this. And again, if I write dx by dt, I can integrate for x because I have to find the distance traveled before breaking off takes place. So I have to integrate 0 to t0. T0 is the time when breaking off takes place. Let us say 0 to t0, the distance traveled is 0 to x because this starts from initially. So at t equals to 0, the distance is 0, the origin is 0. I cannot apply here chain rule, that is v dv by dx. So you see, I tried this one. I thought that you can apply v dv by dx, but you see, if I apply this one, I am getting this side also a time function. So now I cannot integrate because I have dv dx, so I can separate v dv. But what about this side? I will have t and x both variables, so I cannot apply chain rule in this case. In most of the cases, we can apply chain rule, but here since the force is not constant, and that's why I'm not able to apply the chain rule. Have you written or not? If you have not written the last page, I can write this one. If anybody have missed the last page, so this is the last page. So if you have missed the last page, you can copy this one here. And if you have done, that's fine. You have to slightly fast, not very fast. I need slightly fast. This is the second last page, and this is the last page. So you see, this one is the 1, and you can call this as a 2. So this is page number 2. So this is the page number 2. Are you getting? So this is the final solution. Okay, we will go for the next problem. This problem is easy one. So we have to apply. We have to find what is the velocity, what is the displacement. So velocity is a function we can find. We can integrate once again. So we initially, if you see, we have found acceleration as a function of time, and then I have integrated acceleration as a function of time, and I get velocity as a function of time. If I integrate once again, I found distance as a function of time that we are doing. We'll go for the next problem.